Welcome back to Physical Science 20. This is the section 6.4 video dealing with molar mass. So the previous video, 6.3, we dealt with introducing what the mole was, simply meaning the number of things, a huge number of things, 6.02 times 10 to the 23rd. So now we'll go from that and see where that number is useful. So if we have an equation here, a methane molecule plus a water molecule yielding 3 molecules of hydrogen and 1 molecule of carbon monoxide, we can see that the ratio here tells us that 1 molecule of water reacts with every 1 molecule of methane. So we have to have a molecule and a molecule, and it says here simply combining identical masses would not work because 1 molecule of methane and 1 molecule of water are different. Therefore, we need to convert that into a larger number of things. Instead of 1 molecule and 1 molecule, if we were to take a mole of this and a mole of this, i.e. 6.02 times 10 to the 23rd molecules and 6.02 times 10 to the 23rd molecules, it could be measurable and we could work with that number because it's humanly possible to work with that much. So to determine how that would work, we need to know what the molar mass is of each of those. Now here the molar mass is the mass in grams of 6.02 times 10 to the 23rd. So if I had, because we can't measure the mass of a single molecule or a single atom, etc. We need to have something that we can look at. So if we take this number of molecules, which is 1 mole, we can actually measure that. And the units would be grams per mole. Now here's the interesting part. And we saw an indication of it by looking at where the mole came from in terms of the carbon-12 atom. Highlight this, it's super important. The molar mass of an element is equal to the mass given on the periodic table. So if you look on the periodic table, the mass that's situated under, let's see here, neon is 20.18. Well, that is equivalent, numerically equal to how many grams would be in a mole. So the periodic table is made up of relative masses comparing one element to each other by looking at atomic mass or atomic mass units, and we can make it numerically equal if we take a mole. So that's the interesting thing about a mole. If we take 6.02 times 10 to the 23rd atoms of neon, that number that we see in the periodic table is equivalent to what a mole would mass out to be. Interesting. So if we look at various molar masses here, neon for example, according to the table, 20.18, so 20.18 grams per mole. Oxygen, of course, is a Hofbrinkel element. It exists in groups of 2, so we'd have to take the 16.00, which is what the mass of 1 oxygen atom is, double it, 32.00 grams per mole. Phosphorus, which is made up of 4 phosphorus atoms, just simply take the mass of 1 phosphorus atom, multiply it by 4, and we get the answer, 123.9 grams per mole. And when pulling those masses off the periodic table, I tell everyone to go at least 2 decimal places when reporting that number. Okay, so numerical equivalency of atomic and molar masses. So the mass of 1 mole expressed in grams per mole is the same value as you see on the periodic table, so it works out really well. And this just goes through a little proof there that shows that, well, if 1 unit is this many grams, we can see that that is actually fine, and for example carbon would be 12.01. So you could look at that on your own. Now before we move on, one thing that you should copy out is this. So the idea of entities or particles. What kind of particles can you have? We can have atoms. If we're talking about single elements, for example, atoms of carbon or atoms of iron, etc. Atoms is used for single elements. Molecules is used for bonded nonmetals that are together. Hydrogen is considered a nonmetal with many of these. For example, water, H2O, we would say molecules of water or water molecules. If we're talking about ionic compounds, such as metals bonded to nonmetals, like sodium chloride, the term we use for that is formula units. Okay? So atoms, molecules, formula units. So molar masses of compounds, as we saw on the previous page, Fairly easy to calculate as long as we know what the formula is, and you have a periodic table handy. We just simply sum up all of the elements that makes up the compound or the molecule, the formula unit, etc. So for example, carbon dioxide, 1 carbon plus 2 oxygens. Okay? This little learning tip here just kind of outlines what I talked about here, the idea of the particles that we can have, or atoms, molecules, formula units. So here's some examples. Phosphoric acid, hydrogen phosphate, 3 hydrogens plus 1 phosphorus plus 4 oxygens, etc. add up to be 98.0 grams per mole. Now they have this fairly long-winded here. There's an easier way that you can do. You don't necessarily have to show the unit each time. So they're kind of showing the unit each time here. It looks like a lot. It looks difficult, but it really isn't. Sodium chloride, 1 sodium, 1 chloride, 58.44. Sodium sulfate, 2 sodiums, 1 sulfur, and 4 oxygens add up to be 142.05. And here, this represents a hydrate, calcium chloride dihydrate. That dot there does not mean multiply, it just simply means add. So we'd have 1 calcium plus 2 chlorides plus 2 water molecules. So you can figure out what a water molecule is first and then double it, or realize that this is 4 H's, 2 O's, however you would like to do that. So here's an example, carbon dioxide as mentioned earlier. So we have 1 carbon, 2 oxygens, 44.01. And then here we have iron 3 oxide, 2 irons, 3 oxygens, 2 irons, 3 oxygens. Add them up after you multiply, you get the answer. Also another hydrate here, 1 iron, 3 chlorides, and 6 water molecules. And there we go. Okay. Practice questions over here. You could run through these. What I did is I just picked one to do here. I think I picked E. So ammonium sulfide. So if you want, this is how I would do it. So you can see it's a lot less distracting than some of those earlier ones there. So what I would do here is I'd look at this, ammonium sulfide. You can see we have 2 nitrogens, and then 2 times 4, 8 hydrogens, and then 1 sulfur. So I would do that, break the formula up into what each how many of each element you have. So 2 nitrogens, 8 hydrogens, 1 sulfur. Then looked up the masses on the periodic table, going at least 2 decimal places. So 2 times 14.01 plus 8 times 1.01 plus 1 plus 32.06. Multiply those out. So 28.02 plus 8.08 plus 32.06, and 68.16 grams per mole, which is very similar to what I have here. So it could be a rounding issue, etc. So go through these. It's nice because you have the final answers. You can check to see how you made out. Okay, so I think what I'll do there is we'll call it quits with this video, because I'd like you to run through at least a few of these just to make sure you got it before moving on to the next section. Okay, we'll see you soon.